Welcome to this presentation on voltage for test data management. My name is Jean-Michel Guiral. We are going to see how voltage helps generate realistic fake data that represents the reality so that testing can happen properly. The solution is recognized by Forrester that rated Micro Focus with its voltage business unit, the leader in data masking. What is the challenge with test data management? There are different parties with different objectives. DBAs are here to manage databases and have many other tasks in the pipe that can have a higher priority. Also, often copies and masking scripts are manual activities and are error-prone. The QA team are often distributed and even outsourced. Also, the test runs burns the test data, so frequent refresh is needed, even multiple times a day. Finally, given clear production data is not an option for compliance and security teams, it is not acceptable for regulations. So we must make these people all satisfied in the most efficient way. So what can you do? Voltage has a solution to help with these test data management or TDM challenges. What do we propose? You can connect to all databases that exist in the information system thanks to the use of JDBC standard. Why it's important? Well, databases are diverse in IT and heterogeneous is the norm. Second, you can discover sensitive data in these repositories of information, the databases. Voltage uses an intelligent engine with out-of-the-box rules to identify what columns are sensitive. Why it's important? The solution gives visibility as you cannot act on what you don't know. Then you can subset the production database to focus your test on the data set that really matters. For example, you need to test customers in Germany. The solution will extract a consistent set matching the defined criteria. Why it's important? It reduces the storage and CPU consumption. You can also generate test data. That's the main purpose. It can be from scratch or also with production data that we shuffle in dictionaries so that the real data is used to create the masking data. Why it's important? Well, data looks super real as it's similar to what is in production. Finally, you can mask with these dictionaries and also with format-preserving strong algorithm that makes things look real again. Moreover, you can keep the integrity across application, across multiple runs, and even maintain the context in the raw. Why it's important? I would say the context and integrity brings more quality in testing. Voltage proposes to its customers an architecture that helps managing the complete TDM process. This is the concept overview that we see on the screen here. On the left, the DBAs in the IT department first discover any sensitive data. So knowing where is the sensitive data allows to define the masking rules. This information is then used to create automated and scheduled tasks to optionally subset and copy, and mask, and store the data in a central place, a central test data library. Then the testers visit this library via an application in a browser. They trigger the solution to carry out an automated refresh without the need of the DBA and with no impact on the production system, as it is an isolated place. Why it is important? For security, First of all, it segregates the two environments. Testers do not have access to the production data at all. This reduces exposure to risk. Secondly, for compliance, the testers only sees obfuscated and encrypted data. You are in compliance with data privacy rules. And finally, for operation efficiency, IT staff may only refresh the test data library once a quarter, for example. The testers need to refresh their data multiple times a day. This will be done off production with no performance impact on the production system. Let me now show you how TDM with Voltage looks like. The solution comes with a web interface, and we see here the front page with, in white, the core engine and configuration modules, and the additional modules in color at the bottom. First of all, we will see that the solution provides an optional self-service interface for testers. The goal of this module is to present the data management jobs in a way that is familiar to testers to ease their task. I can organize by projects, application with their test suite, and finally modules with the attached test cases. These are the ones that will be attached to a business flow to act on the data. I have, in this example, modeled an environment with an application called Order Management. We have a testing project called Project 1, two modules in this application for customer management and order management. These are our test suites. The customer management module has two functions: to create customers and modify customers. See here that these test cases are mapped to the data treatment function, extract to CSV. In this example, we will extract the data from the database and put it masked in a CSV file that can be uploaded later in the test environment. So I make it simple with a shortcut in the architecture I have proposed earlier on. Let's now run it. So now I am the tester, and I want to refresh my test data because I did some different tests, and my data is not usable anymore. So I need to refresh it. I get into this interface. I see here my dashboard. You see I've run several refresh already, and I can go again in my data generation case, go to the list, and I will see all these cases that we have previously configured. Obviously, I've selected my project here, and I have the possibility to run a refresh. So let's say I want to run the refresh for the test on creation of a customer. I just need to push this single button here to run the refresh. It will call SDM core engine and run the job behind the scene in order to do whatever we have configured. And in my specific case here, I have decided to extract the data from the source, mask it, so mask the different columns with some algorithm in order to put it in a CSV file and have a safe data that is obfuscated and it's not leaked, and there's no risk of privacy on this data. All right, so we have run this job here. We could have scheduled it. Let's imagine we have the possibility, we have a test to run every morning. We can schedule it, and I have now the possibility to go to the history in order to see all my runs. And this is where I will be able to download this CSV file in order to use it in my test environment. So I took here the example of a testing application that allows me to take as an input a CSV file and load it automatically in my test environment. But I could have configured a job behind the scene that allows me to import, upload the information in my test database automatically. So let's have a look at this file, and we'll download the file and show how it looks like. So here we have our CSV. We have, let me show it in this way maybe. So that's all my columns, and they were masked. If I look at the original data, so that's inside the original database, we have our different columns, and if I look at the result here, we have something which is obfuscated and protected so that nobody can see the original data when they are running the test. So we see, for example, the phone has been replaced by some X data, the names have been shuffled, some email addresses has been created. We've changed all the information here, including the social security numbers and credit card numbers, but we have kept some part of these credit card numbers in order to keep them looking like a credit card number. So all this is part of our engine that will, in a clever way, create real fake data in the test environment. One thing to mention is the possibility to have consistency in a row. I did not do it in my simple example before, but we could have configured the job to check the gender column and use separate female or male dictionary for the first name column. Same with the email address that could have been generated from the first name and last name. You also use, behind the scene, the field level de-identification engine from Voltage. It supports many data formats. It preserves the format of the data, so it does not need to change the database schema, and it passes the application controls. And with that, many Voltage customers runs analytics transparently on protected data. Also to mention that the solution uses a NIST standard to compute the de-identified values. I want also to reinforce the point that Voltage ensures consistency across tables and databases. The functions are deterministic and therefore will provide the same anonymized value for each run on the same data. This is key to keep the consistency in your applications. It should not be forgotten that you need to discover first what fields need to be protected. Let's quickly look at what Voltage proposes in that space. So how did we get there? One of the first steps, and very important step, is to identify where are the sensitive columns in my databases. And with SDM, you have a specific tool, module, that will help you with that and scan your databases, any kind of database, and give you a report on the sensitivity of your environment, evaluate the different columns, how sensitive they are, calculate a risk score in your application. And this is based on many different rules that you can apply to scan this environment based on dictionaries, on regular expression in many different countries in the world to identify the sensitive data and classify your information in different categories like personal identifiable information, contact information, credit card information, health information, and so on in these different countries. So that's an important step to help identify where to focus on in the application in order to provide to testers the right information in a safe manner. Finally, let me now show you how I have configured the de-identification job. So how did we get there? So how did we configure this job that will extract the data? Well, we have created a business flow inside SDM, which is linked to our test case. And this business flow allow me to do these actions. I've configured here two examples of business flow, and one of them is to extract to a CSV file. to create this business flow, so this small application, we have a module that allows to do so, the designer. And in this designer, we see our two business flows here, and one of them is the extract to CSV. So that's really here a flow that allows me to do different actions. Here, this is the main action in my flow. I could have a pre-task and post-task in this flow. I could also have interruption, conditions, different script that can run. But here in this simple example, we have a single task. This single task will work, as I've decided in this simple case, to work only on the customer table in my environment. So I just want to do an extract of this customer table. In this case, that was to show that we do not necessarily extract all the information from the database. We only need to extract the subset that is required for the test we want to run. And then we have our action, the individual actions that are defined here, and that allows to do manipulation of the data, extraction from the source environment in a consistent way in order to put it in a target environment. That will be a file in our case, but it can also be a database. So here the operation is quite simple in this case. I decided to copy the data in the destination. I decided also not to purge it, because that's not the goal here. We want to do a copy of the data for the test environment, but be aware that this solution allows also to purge the data in the source environment. And in the meantime, so in the flow, the engine will also mask the data. So I have also the possibility here with all the list of columns that are defined in my application and discovered by the engine. I have the possibility to assign an action, an algorithm that will do the masking on these different columns. So I can decide if I want to mask or not. You see, for example, this one is not masked, and these have been masked with different algorithm, and that's what makes the result that we can see in the interface. I could have also, as we've said, use the other task that we see here, this in-place masking. So that's a job that, in this case, will directly mask the information, obfuscate the information inside the database that I target. So it really depends on my use case and how I've done the copy of the information. Either I can do the copy with another tool that will replicate the database and I want to mask the information in the target database, or I do the extraction and masking in one flow with SDM itself. To conclude, let's recap what we have seen. Voltage proposes an end-to-end solution for test data management, as you have seen. It allows you to identify the sensitive columns, generate meaningful dictionaries and contextual masking functions, and last but not least, define a de-identification strategy to apply consistently across your systems. The solution is flexible in the way it can be implemented, but Voltage often proposes this architecture and concept. You start on the left by extracting the full or partial data from prod. You anonymize it and store it in a central test data library. And now testers can extract the data from there, put it in a CSV file, for example, and upload the data in the test systems. The process can be fully automated. I would conclude by saying that with Voltage for test data management, you get realistic fake data that represents the reality so that testing can happen properly. It reduces the risk of a breach. It gives you test data quality, and it finally improves the automation with a flexible and open engine. Find more information on Voltage for test data management at these links. Thank you for watching.